Very good. Okay. Yeah, so a lot of data. So say if you want to do text analysis, so say you might want to analyze a certain subreddit, or you might want to analyze a website that's made by a subculture or something. This is the kind of thing social scientists sometimes do, humanists sometimes do it. Then web scraping will come in very useful. And a lot of businesses, if you're not less on the academic side, a lot of businesses are based on web scraping. One of the biggest areas of web scraping is like businesses evaluating each other as competitors, and they just kind of keep tabs on each other. So they want to see when the websites of their competitors change, which is kind of a bit, of cloak and dagger, but it is one of the main uses for web scraping. And you'll kind of notice that when you get into deeper into it, that's kind of driving a lot of it. So does anyone have any questions on the high level concept of web scraping before we get into some of the nitty gritty? Okay. Well, let's just jump in, and we're going to start scraping. We're going to start the process of scraping a website, and I'm going to explain a bunch of things as we go. Some of them will be fundamental concepts. Some will be kind of just the nitty gritty of doing this kind of work in Python. And I hope some of the way we do this work will be familiar to you if you participated last week, because we're going to be, at least initially, we might take a step back and then write out a script to do something a little more fancy toward the end, but a lot of it will be dealing interactively with the website in a similar way that we did a little bit of it with some text last week. Okay, so and hopefully it'll feel like a little less of a toy. You'll be doing very similar things, but it'll feel like hopefully a little less like a toy and a little more like serious work, which it is. Okay, I'm going to share my screen. Sounds like someone might have a screen reader there. Cool. All right, so we're going to open up. Hopefully you should be looking at, chat is a little more obscured here, so I'll probably open the chat window. And Philippa, if you're sticking around, can you maybe alert me if there's something in the chat that I'm not seeing, because it might be a little hard for me to spot it. Okay. All right, so we're going to open a.
Yeah, I can do that.
Right, I appreciate that. It's a little hard to keep track of it anyway. Okay. And if I can turn on the screen reader. Okay. So I just opened a command line, and I'm going to type the word Python to get to the Python interpreter. Okay. So you should. Oh, and sorry, OS X people, I didn't remind you guys how to get into it. On Mac OS, if you want to access the Python interpreter, which is what we're going to be using, you want to hit the magnifying glass in the top right of your screen. That's the spotlight search. So hit that, and then type terminal. And then, and I'll do it here the same, and it'll make it look a little more like you. Yeah. So it might look, and then you'll see something like this. It'll be like your name of your computer, and then either a $sign, or you might see a %sign, or a hash sign, one of those, and you'll be able to type some text. And then once you're there at that point, at the prompt, which is what they call the prompt, type Python. And then you'll see the 3 angle brackets, and you'll know you're in the right place. Hopefully it says something like Anaconda 3.8 or similar. Maybe it might not say Anaconda, it might just say Python 3.8 or whatever, but that you're still in the right place, okay? And now, is there any issues with getting to the interpreter that people are having? It's the same as last week if you were here last week, but I know not everyone was here last week. give it a second. All right, well, and I didn't introduce, I'm sorry, one of my colleagues at the Graduate Center, Felipe, I should have introduced. Stacy distracted me, Felipe. It's not but one of my excellent colleagues who teaches Python at the Graduate Center, Felipe Collado, is in the room. So if you write in the chat your question, she might be able to help you, or I'll help you. And you can also chat her privately if you think if you'd be more comfortable doing that. And so if you're having issues accessing the interpreter, that tends to actually be the thing that people have the most issues, is getting into the interpreter and doing that kind of thing. So no shame if you're having a little trouble finding Python. So you go ahead and ask for help. Okay. Okay. So once you're at the Python interpreter, unlike our last workshop, we're going to be using libraries in this workshop. Now, what are libraries? I never got to explain that. So libraries are they're piles of code. They're a bunch of code that someone else has written, thoughtfully written for you. And you can do what's called an import. So you import it into your code, and then you can use it in your own code, okay? And last week I was kind of explaining that everything in Python is an object, and an object can be thought of as like a box. And the box can also contain other boxes, boxes of boxes. And a library, or a module, as it's also known, is just another kind of box. It just tends to have more stuff in it. So if some of the things we learned last week, remember we did string.split or string.find, those kind of methods. Remember we said methods are functions that live inside objects. Well, if you want to think of it metaphorically, those are kind of like tools. They're like a wrench, a screwdriver, whatever. A module is more like a toolbox. So it'll have a whole box full of tools for you, often very many. And it'll be a toolbox for a specific purpose. So you might have a library for data science, like pandas. It's the most famous one for Python for that. You'll have a library for working with grabbing websites and doing things with websites. You have a library for visualizing data. There's endless libraries in Python. There's literally, I don't know if it's up to the millions, but it's at least hundreds of thousands of libraries that exist in Python. And there's a library for many, if not most, tasks that you're going to run into when you're a programmer. So we're gonna need to import libraries, which adds an extra wrinkle to things. So I'm hoping that Anaconda, I don't actually remember if Anaconda has BeautifulSoup, but we're going to show you how to we're going to figure out how to access those if we don't have them. So go ahead and try this. Import requests. So type import requests. Okay. And even for me, it didn't work. I know why that is. It's because I'm not using Anaconda. This won't work on your computer, but my computer has a different setup. Okay. So import requests. Okay. And let me know if that doesn't work. The next one might cause it even more. The requests you probably have. We'll have to see about the next one. If we don't have the next one, we're going to figure out how to install it. Okay. So anyone not have requests, please put something in the chat. And Felipe, let me know if there's questions that are coming up.
There are none. Awesome. But did we start the Python interpreter?
Yes, I give them the instructions to install the Python interpreter, but if people are struggling with finding the Python interpreter, then we can also deal with that. But Felipe, we did a lot of work in the Python interpreter last week, and most of the people were here last week, so
gotcha.
It's surprisingly not a problem. So I'm assuming, can we get at least one person's affirmative that we did actually have? You did have requests. Can someone share in the chat or whatever?
Yes.
Awesome, great, thank you, I appreciate that. Okay, now this one, I'm hoping we also have import BS4, okay? Import space BS4, the number 4. Okay, and then again, maybe someone can affirmatively say we have it, and then we'll see. Just I want to make sure that people have this stuff. It'll be a little bit of a showstopper if we don't have this, and we need to figure out how to do it. Anaconda is really great because it comes with all this stuff, so it really makes this kind of thing a lot easier. Cool. And if you know, okay, we can also share some other environments that are so there's workarounds too. If you're struggling to open Python or something like that, do ask for help because we do have a way we can share like a link or something, and we can get you on Colab or some other environment. All right, so it seems like we have imported our 2 libraries that we're going to use today, which is great. I'll just talk about requests first because this is the library we're going to use initially. Okay, and I'll explain what BS4 is in a minute. Okay. What is requests? Requests is it is a library for making HTTP requests, or another way of thinking about it is for talking to the internet. Okay. So what is HTTP? It stands for Hypertext Transfer Protocol. It is a protocol is you can think of it as a language. It's not really a language. It's more like a series of rules for computers to talk to each other on the web, over the internet. Okay, and it's the language. It's the protocol that most of the web operates on, and we're gonna talk about what actually it might be. Let's do it now. I'll tell you, there's only one thing you really need to know about HTTP to do web scraping. You need to know a bunch about HTML, which is the language that a website is written in, and we're going to talk about that more in a second. But there's one thing you need to know about HTTP, and that is status codes. So anytime you go to a website, and I'm going to open web browser. Anytime you go to a website, so and actually let's go to the website that we're going to use today. So I'll drop the link in the chat, but it's going to be list of science fiction novels Wikipedia. Okay, so we're going to use this list of science fiction novels on Wikipedia this is going to be our target for our web scraping. Okay, so I'm going to share that link in the chat, but what I want to articulate is whenever I go to a website, for example, this one that's in front of us, this list of, let's see if I can multitask, which is probably not the case. Whenever you go to a website, I'm sorry about that massive zoom maker. I'm trying to find the chat. Maybe Felipe, could you do me a solid and just put the link from Google in the chat just for people?
Yeah, I can do that.
Yeah, thank you. I'm sorry. My Python foo is pretty good. My Zoom foo, but okay. And so when you open the web page, there's a communication that happens between your computer, which is in programmer terms we call your local machine. It's local because it's on your desk. It's local because it's sitting in front of you. Okay, the local machine, and the website, which is run on another computer. So there's another computer or computers that's sitting there all day and just waiting for people to talk to it. And then whenever you come up, you make a request of the computer. Can I have the web page? And then it either says yes, you've correctly requested the web page, or it says no, you may not have it. And there's a lot of reasons it will say no to you. Most common is 404 error, page not found. Okay, so if we added some junk, and let me just look at this. So let's just analyze this. for a second. So if we analyze the URL, you've all seen URLs before. I hope. And so we look at the URL. So this is a correctly formatted URL. What happens if we change? We add some junk to the end. I add hello, I like Python to the URL. Now let's see what Wikipedia does. And you can do this if you want to. So Wikipedia doesn't give a 404, apparently. This is actually interesting to me. It tries to imagine that a page exists for it, and then it tells you that the page isn't found. But it's not actually a 404. Let's try another website. Let's try the Graduate Center website, okay? Grad, U.S. Center, CUNY. You don't need to follow along with this if you don't want to. I'm just trying to illustrate the point. Let me grab the URL for this. I doubt they work with URLs as creatively as Wikipedia does. This is not page. I'm just making the URL one that I know isn't on their website. And then it'll say page not found. Okay. And in the browser, that what's come back is there's different status codes for the different websites. So if it's for the different responses. So you make a request and then you get a response. And if it's a successful request, they call that a 200. And if it's a failed request, they call that a 4. It's various numbers, but the most common is the 404, not found. Okay. All right. So let's go ahead and we're going to make a request, but instead of using our web browser, we're going to use Python. Okay. And so we're going to make a request of a website, and we're going to be communicating with the website, and then it's going to return our response. Okay. Back to us. And so let's go ahead and give it a whirl. And right now we want to use the link that Philippa shared. I meant to say, hey, I like Python. Okay. So let's get the list of science fiction novels, and I'll refresh the page to make sure I have the right URL. I don't want to give you guys be using the wrong URL. Okay, that's the correct one. I'm just double checking. And then let's do just write the code out, and then I'll explain it, just kind of like we usually do. Let's call it response. Just make sure the response isn't. I'm just going to make sure response isn't loaded in as a variable somehow. Okay, because sometimes very common words are already loaded in, and you don't want to collide with them. So like you don't want, for example, want to use the word list anywhere in your code, which is very tempting because that already means something in Python and you can mess things up. It's another reason naming things is hard in programming. All right, response equals requests. Okay, and then the dot, remember we used the dot a lot last week. And the dot is how you access something inside something else. Okay, so and in the case of request, it's a module that we're using. So it's accessing a function within requests. Okay, and we do call it a function. We don't call it a method. So I know that's confusing. If it's in a function, if the function's in a module, we still call it a function. And if it's in another object, then we call it a method. You remember we talked about methods. Methods are functions that live inside objects. But in the case of a module, we don't call it a method. Okay. Dot get. If people are really curious about that, I could try to explain it more. But all right, and then I'm pasted the URL, which might be a little hard in your browser. So in Mac OS, it should work if you do the Mac button. I forgot what they actually call it on Mac, the one with the little Mac sign on it. And V, it should paste as normal. Command, okay. And then on Windows, it's a little bit trickier, and it depends on what terminal you're using. If the paste doesn't work normally, it may work normally. Try it, Control V normally. If it doesn't work, you might have to right-click on the window and look for a paste button. Okay. And if not, sometimes on the top menu there'll be Edit, and then you can select Paste. So one of those two things would probably work. And then if nothing else works, you might have to type it out. But I'd recommend against that because it's very error prone. Okay. I'm going to hit enter to see if it works. And then, just like we did a lot last week, I'm going to hit I'm going to type the variable name just to see what the object in the variable looks like, or the object assigned to the variable name. Response. Okay. And notice it says 200. That means it was successful. So remember I said there were status codes, and 200 means success. So that's one you have to look. You at least need to know about 200 and 404. If you get deeper into this, you'll need to know about the other ones too, especially the 300s. But for now, it's 200, and hopefully it's 200. If it's 404, that means the URL is messed up. It could also mean you're not connected to the internet, but since you're hearing me talk, probably are connected to the internet. So if you're getting a 404, or if you're not getting the correct, something else is messed up, the URL is probably being messed up. So the most common mistake that people make when they're pasting the URL in and then finishing, you have to. So remember, on mine, it's I had a single quote, and then I had another single quote. So you need to have a single quote at the beginning and a single quote at the end. And then the most common thing is to have a space before the single quote. So if you have a space anywhere in here, it won't work. Okay, that's a common mistake. Or if you accidentally added a character while you were adding the quote, that could be another issue. Any issues or questions? It feels to me like we probably should have some issues and questions at this point. So maybe I'll let it give a little pause for a second and drink some water. And we'll explain more about the response object. We're going to play around with the response object. But any questions about making requests? And can we get one affirmative that someone did get a 200? At least one person got the 200.
Yes.
Yep.
Awesome. Hey, yeah, there's a bunch of. I love it. Feeling less like I'm sitting in a room by myself.
Just a quick tip on the copy and paste. If you highlight the text you want to paste and you're in your terminal, you hit Alt spacebar, E for edit, and down to paste.
So Alt spacebar, E for edit. Awesome. So you still use your keyboard. That's great. Because I guess the Alt space probably brings up the contextual menu, like the right click.
Correct.
Yeah, awesome. Thank you. I'm a big hotkey person. And anecdotally, programmers tend to be a little bit obsessed with the keyboard over the mouse because it's fast. And also programmers tend to do a lot of typing. So yeah, I like a hotkey. All right, great. So, all right, well, let's dig in then. And I might pick up the pace a little bit here, but I do encourage you to interject if something is unclear or confusing or whatever. But this is kind of the fun part. So let's dig in here. Okay, so what is the response object? So let's use some of the things that we learned last week. So let's do type. So remember, this is the type function. It tells you what something is, response. And it says it is a response object from the requests library. And just for fun, I'm also going to do type on the requests at the module, just so you can see what that looks like. And it says module. So really, this type function is really used. It's incredibly. We're going to be using it a lot as we get into this, because a lot of the confusion around using Python comes from trying to do the wrong thing with the wrong object. And I know you're like, oh, I can keep it straight, but actually no one can keep it straight. So you often need to just be asking what the objects are and checking your assumptions, because you'll assume that you're working with one thing, and in fact you're working with something completely different. Okay. So we have a response object. Now remember, I taught you last week we used this very scary command because it produces a lot of output, but it's the dir directory or dir command. So let's try that, or our function rather. So let's try dir and then do it on response, okay, or response object, okay? And it's going to put out a lot of output. Don't get too intimidated. I'll show you which are the main ones to look at, okay? But it'll give you a flavor of it. So remember, as before, you want to ignore the ones with the underscores for now. Though later in your Python journey, it's sometimes quite useful to know what these as well. They have to do more with Python internals, okay? But actually, they are very useful to know. And you'll notice there's not that many, but some of them are quite useful. So there's a few here I want to call your attention to. I'm just listening to it. So let's do status. So remember I was talking about the status and the status code. So the status code, we explained that. That's the 200 and the 404. So we can do response. And now, remember, I'm not typing out the whole thing. I type out a little bit of it, and then I hit tab, and it fills it in. So response.status. It doesn't really want to fill it in. Status underscore code. There we go. And then open paren, close paren. Actually, I don't think it needs parentheses. So yeah, correct. Okay, then it doesn't need parentheses because it's not actually a function. It is or rather, it's not a method, because now we're actually, the functions here are method. The functions here that we see are methods. It's not a variable, it's not a method, it's an attribute. So it's a piece of data that lives inside the response object. So it's not a function, it doesn't need to be run. I need to get rid of my cat. Yeah. Should probably try a few more times, but okay. So yeah, and so notice it gave 200, so that's familiar to us. And then let's try another one. Let's just do response.status, and I think it will say true. Response, I get a error status. Oh, okay, I don't know if they took that
Attribute
out.
error.
Yeah, it's actually, maybe it's, no, okay. Don't worry about status then. We got status code anyway. And then there's one that is the really useful one. There's one that can be very useful if you're working with an API, which is the JSON one. I won't get into that, but the one we're going to use today is response.text. There's a few other useful ones there, but they're little, we don't really need to get into them today. But this is the one that actually has the body of the response. So it actually has the HTML. Okay, and notice it looks like a big old mess, right? But that's fine. We're not going to be dealing with it like in the form we're seeing it here, but we can recognize that it's HTML. Okay. So now we have, we know that the website came back. We have it in Python. So let's start working with it as a piece of messy data that we have to deal with. Okay. So I'm going to tell you something to type, and then I'm going to explain it. Okay. So it's going to sound a little weird, but I'll explain everything. Okay. So let's type soup equals, like soup, BS4 dot capital B EAU, beautiful soup. So it's BS4 numeral 4 dot capital B beautiful capital S soup. And I'll tell you why that variable of all the other, or that this method or whatever you call it is, well, why this object is capital S and why most others aren't in a minute. And let's put in our response.text, okay, which is the messy website. That's the messy HTML that we just saw. If I scroll up, we can look at it again, and that's messy stuff. And then I think we want to type we have to type one more thing, which is features equals, and then do a quote, LXML. And I will tell you what all this is. I know this seems just like a magic indentation there now, but that's cool. And it looks like it works. I'm not going to type soup to see what it looks like because I know it's going to make the screen scroll. and you won't be able to see it on your screen. So I'll just leave that for a second. So what is all this? Well, first of all, just a reminder, like when we do this equals thing, we've done that once before, right? We've made the request object. We're assigning variables. So we're kind of making transformations of data. And this is a very common pattern when you're writing Python programs or when you're talking to Python, is that you transform some data and then you put a pin in it by assigning a variable to it. Okay, I mean, I hope that's not too obvious to say, but it's a very common thing. You transform the data. You're like, okay, that's what I wanted. Then you assign a variable to that. Okay, and you might do that 10 times in a row. A whole program, a very useful program, might just be you transforming some data 10 times. And so it'll just be variables, and then the next line uses that variable over and over again. Okay. So what is BS4? BS4 is a library, and it's called BeautifulSoup, which is I know it's a funny name for a library, but a lot of libraries have funny names. Okay. And then BeautifulSoup is a HTML parsing library. Okay. And what is parsing? Parsing is taking some messy information, and it could be some input from a human typing into a computer, could be a website, it counts as messy information. It could be well, JSON, which is a data type, could be JSON, could be, which you might encounter in other arenas in Python. Could be a lot of things, but basically it's taking something like often a string full of messy data, and it's looking at it and it's trying to figure out the logic of it, trying to figure out the structure of it. Okay. And then turn it into something that is useful in Python. Okay. And the BeautifulSoup, then so we're using bs4.beautifulsoup. BeautifulSoup, you can tell the capitalization means it's not a function. It is something more complicated called it's either a class or a class instance. But I won't get too into that. But it basically means classes and class instances, or classes and sometimes you could just say object. Basically, it's a way of combining functions and variables together. Okay, which we've seen a lot of already. We've seen a lot of things that just stick functions and variables together, like when we worked with strings last week, and that was an object. Okay, and that was defined. That string object is defined somewhere in a class. Okay. So classes are like ways to define how objects are structured. Okay, but you don't really have to worry too much about it. But just think about it. It's something just a little fancier than a function. But we don't really, for this purpose, you don't really need to know how that stuff works. But as you use more libraries, as you go deeper into Python, you will want to learn what's called object-oriented Python, or object-oriented features in Python. And those include classes and class instances and objects and all that kind of stuff. Okay. And that is what that is. Okay. But you don't have to worry about how it works because it's just provided to you. So you just know how to use it, which is not that different from using a function. And what it's doing is it's creating an object for us. And then we give it a little bit of information that it uses to create the object. So first we give it the messy HTML, that's a string. And then we also give it this one other little line, which is the features equals LXML. And that tells it what kind of parser to use. So there's a couple of choices for that. But whatever, don't worry too much about that. But basically, there's different flavors of parser. You can choose different parsers. And they all have different rules and different ways of handling different kinds of situations. And we are using LXML, which is a very common parser to be used in Python. Okay. So that's a lot of explanation for one little line, but it's a line that does a lot, because now we have an object that is a representation of the web page, this list of science fiction novels web page, and that we can work with in a structured way using Python. Okay. Before we get into messing with it, let's just talk for a minute about HTML. And probably many of you, certainly probably not all, have worked with HTML in some way, shape, or form, or you've at least seen what it looks like, okay? So I'm gonna show you a little trick to peek behind the veil here. So every website you go to on the internet, in your browser, not if you're on Safari. Unfortunately, if you're on Safari, this is not gonna work. So you might want to use Firefox or Chrome or something like that. Or just don't worry too much about it. But if you right click, go to this thing, this very useful option here, view page source. And there's also a hotkey, Control U, which I actually use surprisingly often. And then you get this messy looking thing. And what is this? This is HTML. So HTML is a hypertext markup language. Hypertext means text with links in it. Markup language means a way of describing how a document is structured. Okay, and there's a lot of markup languages. There's XML is a markup language, though it's used for other things as well. Markdown is a markup language. It's not confusing, but it is. Trying to think of other commonly used markup languages. Philippa, you think any coming to mind for you? There are a lot of markup languages, but they tend to be very domain specific. And HTML is probably one of the most widely used markup languages. And it basically describes a website. To describe the HTML, it doesn't describe the presentation of the website, the colors and the shapes and the alignment and all that kind of stuff. That's CSS. What it does is it describes the semantic structure of the website. Remember, we used that word semantic last week. Semantics is meaning. It means it's the meaningful structure of the website. So the kinds of things you'll see in HTML are things like paragraph, list item, title, things like that. They're meaningful things. Not to say that visual information isn't meaningful, but it's much more ambiguous. Okay, so this is explicit semantic information that can be understood both by humans and the computer. And like, wow, there's a lot of stuff on this webpage. What is all this stuff? This stuff is interesting. I think this is. Oh, this is the sidebar. List of fictional robots and androids. Man, I love Wikipedia. The world would be a lot more impoverished without Wikipedia. Okay, so scrolling. So what do we want to look for here? So I'm going to tell you what our goal is. So you can kind of see things that you would see on the website. You can look at stuff and kind of be like, yeah, I can figure what that is a little bit. But let's be a little more intentional about it. There's one thing I need to explain about HTML before we proceed. So that is that HTML, it's what's called a tree structure, okay? And it's kind of like your hard drive has a tree structure as well. A lot of things in programming and computers are tree structures. Even a lot of things that we are doing in Python, where we have a, remember I said objects are like boxes, and you can have other boxes within those boxes. And that becomes a tree structure. So basically, a tree structure means you have a central root. You can think of it as a central box or a central holder of information. And then that box has other boxes in it, okay? And on and on and on. You can keep opening new and new boxes until you can't anymore, until you get to the bottom. But then what that creates is like a pattern. Let me see, can we get a picture? Tree structure, just so you can visualize a little bit. Images. There we go. So it's kind of like that one next one is a simpler one. I like this one better. So here's the tree structure, right? So you have the root, which is the top, which is the origin of everything. So it's the box that has all the other boxes in it. And then they branches out. And so like, there's two boxes in the main box. And then inside this first box, there's two boxes. In this particular tree, it's what's called a binary tree, which basically means each box has two boxes in it. Okay, and it's used for some very specific things in computer science. A binary tree is used for search algorithms and stuff like that. But basically, our trees are messier than that. Okay, a box contain an arbitrary number of boxes in the trees that we're using. Okay, so that's how HTML works. HTML has a central let's just keep using the word box. It is a central box. In HTML, they're called tags or elements. They're called elements in this context. So, and it has a central element, and then each of that central element then will have many elements in it. So the central element is always called HTML. So there's a tag here up at the top somewhere that says HTML, and everything else is under that. Okay, and you just have to understand that when you're working with HTML, there is this tree element. Okay, and we're also going to see that there's dimensions. So if you imagine you're moving through the tree, then there's a down, right? There's a down and there's an up, right? Because you start at the root and then you move down. I don't know, and they always say roots are always visualized at the top, which is kind of confusing because in a real tree they're on the bottom, but whatever. There was a root and then you move down into the different elements, the different boxes. And then you can also move sideways. Do we still have that? Yeah, the tree. You can move sideways between the elements. So these are what are called siblings because they're sideways relationship. Okay, this is a parent because and this is the words people use. These are siblings. Okay, this is actually the technical term, siblings. It's not a metaphor that I'm making up. I mean, it's a metaphor that other people made up. And then the parent is the thing it comes from. Okay, the thing that's closer to the root. It's up. And then the children, very family oriented. The children are the things that live in that are below. Okay, so children are below, parents are above, and siblings are to the side. Okay, and then you also have an idea of in HTML, you can also imagine things as next, as going forward. Okay, that's another way you can visualize things, and this is also will be very useful to us. So if you were to say next. First, in BeautifulSoup, when BeautifulSoup handles next, it starts with HTML, and then it goes off to the side like this, and it keeps going down until it can't anymore. And then it goes to the next thing, and then it goes up and out, okay, to the next original thing. Okay, so next would be like, okay, down, and then over, and then up, and then down, and then over, and then over, and then up, and then down. That makes sense, okay? So that would be the idea of forward and backward. Those are another way you can imagine moving through the HTML. We're mainly going to use that next one, but you also, if you're going to get more into this, you need to understand about the parents and the children. It's kind of okay. That where are okay. So let's actually define our goal here. So our goal is Goodbye Graduates on our website. So we have our list of science fiction novels. I want to get a list of, let's try to get the text of the titles of these books, okay? So we want the text of the titles of these books, okay? And you're probably like, well, why can't I just do this and then kind of clean it up? Well, you know, I mean, there's some obvious problems with that. What if there's a million items? What if the items are spread across many web pages? So we'll talk about why it's more useful to do it programmatically, which is to do it in Python. Yes, you could, for this amount of data, you could, with some effort, copy all of this, and then, but that would only give it to you once, and it would, blah, blah, blah. So I'll explain why they're doing it in Python is more powerful. You can probably kind of guess why, but I will talk about that later. But okay. So our goal is we don't want all this other junk. We don't want the sidebar. We don't want the headers. We don't want this. We don't want the heading. We don't want the headers. We don't want the bullet points and the things. And we don't want anything except the titles. And we want the titles in a nice list in Python so we can do something with them. They do stuff with them, okay? So how do we do this? So in web scraping, and this is why web scraping, another reason web scraping is a messy art. It's because every web scraping job is different. And why is that? It's because every web scraping job is defined, you have to work backward from the structure of the web page, okay? So if we want to we want stuff from here onward, then we're going to need to find out where this is in the code, in the HTML, the 0 to 9. We have to take a look at that. And then from there, we can try to grab stuff forward, try to grab all of the stuff forward. And so we're going to start by trying to find this tag. Okay, so we're going to find this tag we're going to find this needle in the haystack. Okay, so this 0 to 9. And honestly, so I'm going to do this the way I would actually do it in real life, because I've done a lot of web scraping jobs. It's like one of the first things I do in Python. It's the thing I do pretty frequently because I like data and it's useful, and it's a useful thing in security and other things like that. So, but this is what I would actually do. So I actually be like, first of all, I'm going to say to myself, you want to find a unique item, the item on the page that's likely to be unique. Now, often you would want to look for like a container for all the data. So if there's something that suggests itself as a container, then that is the easiest thing to work with. But this is actually, I would say, a more medium hard job where there's no container for the data. No, like if they were all in one list, that would be a lot easier for us. But they're different lists, so it actually makes it a little bit harder. So what I'm actually going to look for is the closest thing I can come is probably to just find this first heading on the first list. And then we're going to try to get stuff forward from it, okay? And we can worry later about the junk at the bottom, because there's other list items after the books. Like these are also lists, which is kind of a pain. But you know, I'm going to show you how to actually do things in the real world. It's always a messy job with web scraping. Okay, it's always a messy job. So it would be nice if the list there were no list type things afterward, but it isn't the case. So we're going to have to just deal with that later. But we're going to start from here. We're going to find the 0 to 9. So this very simple low-tech way of starting out is to go to HTML, Control F, and go 0-9. I can actually, I'm going to zoom in and make sure I didn't mess it up. Yeah, there we go. And so in my mind, I was like, what's the chances that there would be other things on the page that are 0-9? And so you want to find something fairly unique. You don't want to find something that you're going to find 50 of them on the page. I mean, if you don't mind looking through it all, fine. But like, but you want to find something as unique as possible to start with. Okay, place to start. And so actually, this instinct is good. And I think this is the only 0 to 9. Well, there's actually another one down to the bottom, but we don't have to worry about it. This is the one we actually want, and we can confirm by actually just reading it. So H2 span class ID equals 0 to 9, and a bunch of other junk. And so in HTML, let's actually copy it out, and we can kind of analyze it a little bit. Okay. So I think that's the thing. Copy. I'm going to go to my little text editor. You can put it in VS Code or whatever, or you can just follow along with me here, because I'm just going to break this down a little bit. Okay. So what are the elements here that are most important? So, so there's two things that we're dealing with here in Python. So one is first that we have a H2 here. Wow, I think this is actually messed up. Span class. See, this is the thing. Normally it should look like this. It's kind of weird that it's actually malformed. I think there's actually a mistake. But this is very common in HTML. Is that span class. Yeah, I don't know. It's odd because the H2 is empty, which it really shouldn't be. Oh, I see what they did. They did something a little bit different, but it's a bit messy. It's messy. It's really the takeaway here. They put a bunch of junk inside the H2, which was confusing me. So what is a H2? A H2 is a heading. So if we go back to the page, this is the first heading, this is the second heading, or this is another heading. So H1 is probably this, okay? And we'll play around with that, we'll find these things. H2 or probably these, I'm just guessing at the structure. We can confirm it in Python, but I'm guessing at the structure. These are probably the H2s. And then maybe there's, I don't know if there's H3s or anything on the page, but basically it's nested headings. So you have the big heading up here. You have these headings that are the same size going down the page. Okay, that's the H2s. And then you have, what else do you have? You have this stuff. So you have span, which is basically a meaningless element in HTML. So it's not actually good practice to use it for this kind of thing. But it basically just means just another element. It has no meaning. It has no semantic meaning, which is bad. But it basically means another element. And then it has these attributes. So attributes are kind of like variables that live inside the HTML tag, which defines the element. Okay. So in this case, it's class equals something that doesn't look that useful, because I'm guessing, I didn't actually confirm this, but when I was looking at the HTML earlier, I was guessed this is probably used all over the place, this class. And classes tend to be used repeatedly on the page. So they don't tend to be that useful for scraping to find a unique value. So, but what actually is useful is this ID, because IDs have to be unique. That's a rule in HTML, is that IDs can only be used once on the page. Okay, so they're often really used to find something in web scraping, to find a needle in the haystack. And notice it's got the 0 to 9. So the first thing I want to do, I'm going to show you a few different things, but the first thing I want to do is the first thing we're going to do when we get serious is we're going to grab this element here, this span, blah, 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 blah. And we're going to use this ID to grab it. And IDs are really useful in web scraping because they're unique. Okay, they have to be unique. So they are very useful that way. Okay. Sometimes you can just be like, okay, there's only one element on the page. You could just be like, okay, well, it's the only list on the page or whatever. But often we need more unique. So let's go back to our Python and actually do some stuff. So we have our soup. So our soup is, if we just type soup to see what that looks like, it's the whole page. And notice it looks a little tidier now. It's been parsed by Python, okay? And basically, it's ready for us to explore. And I'm going to show you how working with this soup object works, okay? Digging into the HTML, okay? There's a lot of useful methods inside the soup objects, okay, that we've created, okay? So it's and we can just do a quick dir. Well, first we could do type soup, and it should say the beautiful soup object from BS4. And then let's do dir on soup, and we're going to see all these useful functions. There's a lot of useful functions. Unlike requests, there's actually a significant number of useful functions here. And I'll show you some of the main ones, okay? So don't worry too much about most of these. But notice it's got a lot of utility for digging into the HTML and exploring HTML, okay? So we're going to, first I just want to show you the basic way the soup object works. So I'm not going to define any variables yet. So I'm just going to kind of play around a little bit. So let's try a few things. So soup.title. Okay, soup.title. So that's another kind of rule in HTML, is there should only be one title for the web page. And the title is actually, it's not this at the top of the page. Kind of maybe weirdly, it's not this. This is a H1 element that just appears at the top of the page. It's actually what appears in the tab up here. That's where you see the title. Okay, or you will see it on Google. The title is what appears on Google. So if we go back to Google, list of science fiction novels, that's the title element. Okay, and it actually appears in the heading in HTML, not in the body. It's data about the page rather than stuff on the page. So the title. So you see, we get the title tag. We get the title tag, and then it has some text inside it, and then it closes another tag that closes it. So this is what's called an element. So it's two tags with some stuff inside it. That's how HTML works. You have tags that define the element. So you have an opening and a closing, okay, and some text on the inside, okay? Now, what if we only want the text? So we did soup.title, and that worked because there's only one title. So it gives us the first. It gives us the first element that has that tag. Okay, so it's the first item that has a title. In HTML, you only have one title, so that's fine. And then what if we want the text from it? We can actually do this. soup.title.text. And then it'll get rid of the title tags and just give us the title, which is actually pretty useful to get the title of the page, okay? So that's the most basic operation on the soup object, okay? is you can just do things like soup dot, what else? We could do soup dot h1, see if that does anything. And look, that got us the h1 element, which is what appears at the top of the page, okay? We can also do soup dot h2 and see what we get. It should give us the first one. Oh, wow. And actually, that gives us what we want. So actually, that's an even easier way than I was planning on showing you to find it. So that's actually pretty easy. We can just do soup.h2 because the first item we wanted, the first heading, number 2 item, is actually exactly what we want because we're going to want to get everything forward from that. So that's actually pretty, we could just stick with that. So we could do soup.h2. And we can also do that text if we want, just to see. Oh, yeah, 0 to 9. And so it's our 0 to 9 object, just like we have here. Now, what if we wanted to do what I said, which is search by ID? Then you can get a little fancier. Okay, so you can do soup.find. We'll start to find specific things. And you can use a little bit more sophisticated syntax here. You can go H2, you could go, you could type something like ID equals 0 -9. Okay, so you can find things by ID. And it'll also give us the same element that we had before. Okay, and there's other, you could also do class, you could find by class, you could just say class equals whatever that class was, you could do stuff like that. Okay, but basically, if you can find something on the page, you can search it. You can also get all of something. You can do soup.find all, and then let's do all the H2s. Okay, so this is all the heading, second level headings. Okay, but it looks like kind of a mess. It's a lot. It's too much, I would say. Okay, so let's look at that again. Let's define that. Let's just do something really quick. You don't have to follow along with this, but I'll just show you really quick. I might use this as an opportunity to show you something because we're going to have to do more. I'm trying to decide something. Actually, I'll leave it. I won't dig into this, but you could dig into this and you can get the text of all of these, and you'll notice, you know, they go all the way down the page. So it's A, B, C, D, and then there's some stuff on the bottom too. Okay, beyond. So that's the H2s. Or you could do soup.find all, and the A tags. This is very useful. The A tags. What are A tags? They're links. Okay, and it's the A tag will include the actually, let's just do soup.a to get the first one. That's not very useful. It's pretty. That's interesting. It's a very empty A tag. So let's do soup.find all A, and we'll find all the links, including the text on the page. So this is another big mess, but it's all the links on the page. And if you want all the links that if you want all the link items that actually have hyperlinks attached to them, you could do, and this is also very useful, href equals true. And href is how, if you scroll up for a second, you'll see them all over here. Href equals blah, href equals blah. Href is how the link is defined. So it'll be A, find one here. A href equals, and then you'll have the link. Okay, that's how the link is defined. It's kind of like the variable inside that tag. That's how the link is defined. And so that gives us only, this should give us only the ones where it actually has a link associated with it. So if you didn't want the ones that were like the first one, you know, which was empty, soup.a, that's an empty one. It is just like, I don't know. I guess it's so you can click a link that brings you back to the top of the page. It's not very useful to us. So if you wanted to skip those, you could do the href equals true. So that means it will check to see if that tag, if that attribute exists. The attribute is the little variables that appear inside the tag. Okay, like the link. Okay. So that's just a little tour of the things, some of the things we can use. We can use find. We could do soup.find, which finds the first item. So you could find the first H2. And you could also similarly just do soup.h2. It's kind of the same thing. Okay. And then, or you could do soup.findAll, which will give you a list, and that will give you all the H2 items or all of the items of that element. And you can see how this be useful. You can just grab all the links from a page, stuff like that. Okay. I just want to pause for a sec, have some water, but it's a good time to ask questions. If you have questions. But we'll actually grab that element that we had picked out before. And if you do have questions, just drop them in the chat. Felipe will let me know, or you can just get on the mic and ask a question. So, okay, let's actually do the scraping. So let's do soup dot. Let's do it the simple way since it works. Soup dot H2, and that gives us, you know, if we wanted to just look at the text, so it's left, and that's the text. It gives us that 0 to 9. Gives us this, okay? So that helps us find that. So let's go ahead and do that, assign that to a variable. Soup.h2, and let's just call it, I'm gonna call it, start, it's always hard to pick out the, let's call it books start. And there's a lot of ways you could go there. I could have called it 0 to 0, 9. I could have called it first element. I could have called it whatever. It's hard sometimes to name variables, but I'm going to call it books start. Okay, so that's the variable. That's the thing. So books start. Okay, that's the tag, and you can do book start text. You know, all that kind of stuff. Okay, so now I want to find everything forward, everything of a certain element forward from here, forward from this place, okay? So I'm gonna use a new thing. I'm gonna do books start dot find all next, okay? Find all next, okay? And that is the same as find all, except it's find everything forward from that tag, okay? I also didn't do type on books start. It should say it's a tag. It's an object that represents a tag. Okay. So yeah, HTML. Yeah, document.tag. It's bs4.element.tag. Find all next, and then what we want to do, and if we look at the HTML, we can see. So if we look at, I don't know, what's the first book here? It's called. Let's just look at Galactic Effectuator. These have some crazy names. And then notice we could look at a few different things here. So we could say, which do we want? Do we want, it's LIA. Let's just analyze it in the, let's take a quick look at it. It's LIA href. So remember, A stands for anchor, and it basically means it's a link. And the link has the href, which is where the link will take you to. So we could actually open this up if we wanted. Well, that doesn't work, but whatever. Oh, you know why? Because it didn't have the front of the, but we could add that back in if we wanted to open it up. It doesn't have Wikipedia.org or whatever in front of it. HTTP Wikipedia.org. It just has that. You're allowed to do that if you're on the website already. And then it has some text. So it says whatever, Galactic Effectuator or whatever. Oh, it says Jack. So we could get the LI, we could get the A tag. There's different ways we could go here. I'm going to say, let's get find all next. Let's just try the A tag. We could try the LI and we could try the A. Let's try them both and see how messy they both are, or see how well it works. Just try things out. Okay, find all next A. So find all the links. It might find too much though. Yeah, it's a lot of junk. A lot of extra junk that we don't want. So a lot of stuff from the bottom. Boom 2. But it might still be the way to go. So we could also do the same thing, except we do look for the LI. So the LI stands for list item. So it just means, you know, every time you see a bullet point on the page, it's a list item. These are all list items. But then they're also the two links, right? So you have to think structurally. Be like, well, what's the most useful thing? But I guess I'm going to go with the LI, okay, for now. So I'm going to get all the list items on the page. I could get all the links and try to deal with that. But I think I would wind up with a bunch of links mixed in that where the author looks like. So I don't actually want that. I want only the book. So I'm going to do LI. Okay. And then get all the list items. Okay. And then on the rest of the page, and I'm going to call that LI and just put an S at the end. LI, it's list items. Or I could write it out. List items equals, just for less confusion. List items, underscore items, okay? And now we have type list items, and it'll say it's what's called a result set, which basically is a list. It's a bs4.result set, I think. Yeah, element.result set, okay? Which is basically a list. So now we basically have a list of them, of stuff. So we can do what we did last week and do a loop, okay? Now it's a little hard to write a loop in this environment, right? If you were in VS Code, you could write a loop a little bit easier. And we could do that, but let's see how far we can get making loops in here. And I'm going to show you a syntax for the loop. Now it's a little more compressed. It's called a list comprehension, and they're tricky. So I'm sorry if they're a little annoying, but basically if you want to do, you know, we have all these items, we have all these list items, and we want to extract the text from each of them, okay? So let's do list item, that's going to be our kind of variable name, dot text. Remember that we do the dot text if we just want the text of the thing without the tags, without the fancy HTML stuff. For list item in list items. And basically what this is saying is go through this result set, which is basically a list. It's the same with like a list we did last week. It's a fancier name for the object, but it's basically just a list. And we could do dir on it to see what it contains, but you'll notice if you do dir on it, it's going to be all the same methods as you would see in a list, like append, reverse, stuff like that. So you can look, you could do dir on it and be like, yeah, it's basically a list. So we can, and then this is basically defining a variable name. Remember in the when we did the for loop, it had three things we had to pay attention to. And one was the body, which is what you do. That was the thing after the semicolon, after the colon. One was the thing you're going to loop over, which is over here, the list items you're going to work on. And then you have the thing you're actually, then you have the variable name that you define. So this, in the list comprehension syntax, it loops through and it creates a list based on what you're asking for. And this is what you loop over. And I'm sorry, I know this is confusing. So just if this part is confusing to you, just kind of let it wash over you, and it will come. And if you work on, if you kind of bang your head on it like three to five times, it'll make more sense. And looping is always hard when you're beginning programming. So I'm sorry for that, but it's, you know, it is what it is. So this is the thing we're looping over. This is the variable name we're giving each item in the loop. Remember, we did that last week. Each item in the loop. This is the variable name that has changed. So every time we loop, it gives this the variable name. And this is what you actually do to it. So in this case, we're like, whatever dot text, list item dot text, because we just want the text of each item in the list. And here we go. We actually have the text. It's still kind of messy, but I wonder if there's a way to make it a little prettier looking. You know what? I could wrap it in print just to make it prettier looking. So you don't have to do this. Don't do this, but I'm gonna do this so it's a little prettier so we can actually, I'm just gonna wrap this in print. Remember the print function we learned last? And it will make it a little tidier just for our human eyes to make sense of. So notice a lot of them are none. It's not useful. But we want to get rid of those anyway. That's a bunch of junk at the end. So there's a bunch of like empty list items here that don't have text in them at the bottom. It's a bunch of junk basically after this. And that's why we see all the nuns, because of that junk. We scroll up and then we see here, we have like about Wikipedia, all that kind of stuff. So that is kind of down here. That's like the about Wikipedia. And if you scroll further up, you see things like a lot of links here. It's a bunch of Wikipedia stuff. Hyperspace. There's a lot of topics. Titma, Tokusatsu. These are, and now these, okay, these are the actual books. And then if you see down here, you would see these are other related things. So at the bottom of the page, it has like related things. So it says, you know, classics of science fiction lists, that kind of thing. And here it has see also. So we don't actually want that stuff, but you will see it here because they're all list items too. List of times travel science fiction, all that kind of stuff. That's here somewhere. So if you scroll up a little bit, you will see the books. White by Ted Decker, whatever that is. The Wind from Nowhere by J.G. Ballard. Namely, an Image of Voices. Okay. All right. So now, in order to get rid of this junk, we're going to have to write a real loop. We can't just write a list comprehension. So, because we have to use a slightly fancier thing. So, I just thought of a way to try to do it in list comprehension, but I think it's too weird, so I'm not going to try it. So we actually want to get rid of this junk, basically at the bottom. We could play around with this without, but we want to get rid of the junk at the bottom. So I'm looking at the time. I'm trying to decide if we want to try to write a script, but it may be, we may not have enough time. Maybe we should keep trying to work in the REPL. But let's try to write a loop in the REPL. And I know it's kind of hard. At this point, I would normally switch to writing a script in a text editor because, you know, it gives you a little more power. Like now that I know what I'm doing, you know, I would switch over to writing in a text editor just to give myself a little more elbow room or whatever. But you'll notice like it is really nice to use the REPL when you're exploring the structure of the thing. You know, when you're kind of poking at it and you're like, soup.find this, soup.find that. It's pretty annoying. It's not as fun or interactive to do it in the script, even if the script is a little more, gives you a little more elbow room in terms of like writing fancier things, if that makes sense. So, so let's see if we can let's try to get all the hyperlinks, and then I might just get the first 100, and then we could try to do something else with that. Okay. You know what? Let's yeah, I guess we won't do the script. I'm tempted, really tempted to start a script, but I know that would probably go over time, which is not good. So okay, let's do first we want to let's see. First, we want to, let's just get all the hyperlinks out of this. And then we will try to do something with the first, or you know what, let's just play around with the first 100. And I'll show you a couple of things. I'll do a quick tour of some fancier things you could do with this at the end. I think that's the best compromise here. I'll show you, and I can share the script with you at the end. I have a script here that does a little fancier, and I can give you a quick tour of that. And then I'll share that script with you at the end. I think that's the best compromise here. So let's just get the, we'll we have our, let's take out the print. We don't need that. Okay, I'm just going to confirm that that's correct. So we have this, okay? Let's assign this list to a variable. Okay, so remember it's the list item for list item in list items, or list item.text. So it's basically just this, all this does is it grabs the text out of it, so we don't have the whole messy HTML. We just want the text of the titles, okay? And then let's call that books, even though it's not quite books yet. It's, you know, it's a bunch of other junk too. Okay, so books, and let's just do a little quick poke at it. So we could do books. So remember that, what type is this? Books. It should be a list. So we can do the things we learned last week with it. Okay, so we can do books. We can do this square bracket syntax that will give us where we can look at different numbers. So we can kind of poke at it and be like, okay, how far in? Okay, so if we do the 200th item is, it's only D. So let's go many more. Let's go 1,000. Because it's alphabetical. 1, 2, 3. This may be too far. Okay, that's S. Say on, let's see if we can get to Z. Let's do 1,200. Cite this page, that's too far. So we know it's somewhere between those. Let's do 1,100. List, whatever that is. Let's do 1,070. If you get to like Y or Z, that anime. Okay, it looks like that 1140. We're trying to center in on it. Political ideas. That doesn't sound right either. I want something that starts with a Z. So 1,020. Grandmaster. What is all this? Let's go back to 1,000. Seiyun. Let's look on the page and see what this is. Like, we could actually look at the page and confirm. To search. Oh, actually, we went too far. I thought maybe it was a book title. So we actually want books. Let's try 700. That looks more. Yeah, that's more titly. And let's do 800. To live forever. Yeah, that's a book. Let's do 900. The zap gun. So that's a Z. So let's just call it there. We could go forward. Zap gun. Oh, that's actually really close to the end. So 1, 2, 3. We can do books. And what was that? That was we could do 903. Maybe. Oh, nice. That is actually the last one. Z is for 0. So so let's just grab out those, and actually that will be our book title. So that's actually pretty handy. So let's do books 0, or actually we could just do. You could either do 0 to 903, or you could just write empty. Don't skip the 0, and it'll assume you mean the beginning, which is kind of nice. So we can do that, and that will give us. It'll cut out the rest. It'll give us everything from book 0, which is the first one, to book 903, which is the when Andy Weir book. Okay, and that's the list. And let's assign it to a variable. Let's just, we could just overwrite our books variable, but I'll call it books clean. Well, let's just call it books because we're going to be using it a bunch more. So I don't want to say books clean every time. Okay, so now we have this cool list, which is 900 science fiction book titles. And we can do a little of what we did last week if we feel like it. We can do things like we can poke at the titles. We can search the titles for specific things. So we could do like book or book in books if book or if, does someone want to tell me a word to search for? Just so we can get all the books that have a certain word. Maybe a funny word. You guys got this.
We can try 0.
A 0. That's interesting. Okay.
How do you
If
do that? How you do that? Oh,
if 0 in book. Okay. And I put a capital in because I'm going to assume a lot of them are capitalized. And I can explain the syntax a little bit too. So it's book for book in books if 0 in book. Okay. Actually, not as many as I thought. There's only a few that have 0 in it. Count 0. No, Count 0. I don't know that book. Count 0. William Gibson. He's the person who wrote The Neuromancer. Tell 0 by Paul Anderson. So that's kind of interesting. What about
Patrick?
Yeah.
Someone pointed out in chat that the last book did not show up.
Oh, interesting. So it should be 904.
904, yeah.
It should be 904. If you wanted to fix it, well, I overwrote the variable, which is kind of a pain. So I'm not going to actually fix it. But if you wanted to fix it, it would actually have to be 904. That's a very common error in programming, which is called an off by 1 error. Basically means you're off by 1. It's actually one of the most common types of error that you get in programming. It's surprisingly hard to do that kind of work where you slice lists and get the right number of things and stuff like that. And I mess it up all the time.
It's because the value, the last value is exclusive, right?
Exactly. Yeah, it's confusing. And in other languages, it could actually be handled differently. It's just Python. And there's reasons they chose to do it that way in Python. It does make sense, but it is, in some contexts, it's confusing. They just had to make a hard choice.
Python also does it where the first index is inclusive, but the second one is exclusive, which you have to remember
man,
as
how do you
well.
say hi?
Yeah, I know it's confusing, right? But I've learned many times why they need to do that. And it's basically because, but I always find it a little hard to explain and it's a little hard for me to remember. But basically it's because it's confusing in other contexts if it's one off. In that context, it is confusing for when you're trying to grab the whole list. But in other contexts, it's confusing to have it the other way. So it just is what it is. And because of that, you'll often get these off by 1. And it really, I think if you sat down with a piece of paper and you had all these like lists of like scenarios, then it would be a logical choice that they made to do it this way, but it is kind of confusing. Okay, let's try. I'm doing if, well, empty, not useful. If I'm gonna look for, I don't know, something more common, like what about planet? So there's a lot of planets, as you can anticipate. The Secret of the 9th Planet. Big Planet. Oh, there's a C.S. Lewis novel here. Did you know C.S. Lewis wrote I think is it the, I forget what it's called, the Mars trilogy or something? Yeah, he wrote a space trilogy, C.S. Lewis, the guy who wrote Chronicles of Narnia. So I want to, that's basically as far as we'll go in the REPL. And let me know if you have any questions about any of the stuff we've done. I want to quickly give you a tour of maybe how to do something a little bit fancier so you could get a sense of how creepily powerful in some ways web scraping is. So maybe take a couple of minutes for that. So let me just open it up and I'm just going to give you a little quick tour. So I have this example file for you. Scraping tutorial here. Okay, so let's just do a quick look at this. So this is how, basically, it's what we did, but in script form. So if you wrote out the script, it would be like this. And I guess I can try to put this in the chat really quick, just in case some of you want to follow along. Let me grab the chat out here. These are some of the hotkeys working, some of them don't. Okay, copy the whole thing out. And then, so I don't know how useful pasting the code in will be, but in case you want to sort of, it probably will break if you just paste it in yourself, but in case you want to kind of see how things work, or if you want to try it out yourself, you really want to try it out yourself. But I would say you could just sit back for a second, and I just want to show you some quick things. So one of the things I want to impart to you about web scripting, which is a bit of an awesome responsibility, is that there's can be a bit of a sorcerer's apprentice element to it. So one thing you could do, and I'm actually now very tempted to do it with the science fiction books thing, which is now there's all these links, right, that we have. And what if we were then to follow them programmatically and then grab all the text? And then we could have one big data set that is all the Wikipedia articles. So we could go to each of these and grab all the text and then see. So I kind of just want to help you understand that is the kind of thing you can do. And it's not even like if you can do what we've done up till now, doing this it's not even that much more complicated. So what do we do here? This is exactly what we did before. We did our import. So we imported request in BeautifulSoup. We did request.get. Soup equals BS4. So that's our soup objects. Then I called it beginning books list, which is not a great, but that's the first element, right, that we got, the 0 to 9. And in this case, I went with grab the link. Instead of grabbing the list item, I grabbed the link. Now, unfortunately, that will have the authors mixed in, but whatever. For link and links. And then here we have a loop, which is kind of what we did with the list comprehension. Remember, we did the square bracket like for, list item dot text, all that. This is kind of like what we did here, except this is a different syntax for it. So for link and links, the links are all the A tags that we find on the web page. This is another way I found to end it. Instead of doing, list item 903 or whatever, I could just make it more like what we did. So we could do, we'll call it, what do we say? Books equals beginning books list dot finds all next, and then we got li, and then we could do something like let me just check that works. Projects. Python. This is kind of like how we ran the scripts last week. Just running the script. It looks like it worked. Beginning books list. So let's do the for book in books. And we can do, well, let's first just grab to the 103rd item. So let's say books equal books from the 0th item to the, what was it again? 904, right? That was the correct one? It wasn't 903, it was 904. So we can at least get it right here. And then let's do for book in books. And then let's get the link out. So we can do book print book.a, and we'll see what that comes out looking like. just really quick. We're running it. So it looks like it's giving us the A tag. Ahref equals. So but we actually want this href thing, right? We don't just want the A tag. We actually want the href thing. And I'm trying to remember how to get that out. I think it would be something like book. Book.a.get href. Let's just try that. It might probably won't work, but probably be an error. Yeah, that didn't work. You could do, I think maybe we could, can we possibly do this? Book.a href. I just can't remember quite the syntax for grabbing the element out. No, doesn't like that. Dot href. Trying different things. Okay, I'm being a little lazy. The link. That'll be a little annoying if I can't actually get the link out. Oh, it's get attr maybe. Href. I think that might actually work. Oh, because there's nuns in here. Let's try if book. I can explain why this works if it does work. All right, I want to grab all the links up. Book that. Let's just see if it's getting anywhere. Okay. Well, okay. I won't distract you. I won't go any further down this path, but I guess if I had another 10 minutes, I don't want to make you watch me debug it. But if I had another, but basically this is a very common pattern, which is to grab all the links out, all the href tags. I could just look it up, I suppose. Grab all the href tags or all the links out. I can actually figure out how to do it. And then you can actually follow each of those, which is kind of, you know, you follow each of these, you do a request.get for each of them. And then you can start grabbing the data from each of those. And that is actually kind of how Google works. That you know, Google actually has a much more sophisticated version of this and a much larger version of it. But they have what are called spiders, which are basically programs like this that go on a web page, they find all the links on the web page, and they travel to other web pages over and over again. And then that's how they build their index of web pages on the internet. And so you could actually do the same thing and follow all the links on a page and then do something with that, like grab all the text from there or grab all the links from there. And that's very common in a scraping project, is to do things like that, is to, if you want to scrape a whole website, or if you want to grab data from a whole bunch of different web pages. And then you would repeat the process of what we did with the first page. We would actually look at the HTML and try to find the correct things. And sometimes the logic could get very complicated. Like you might be like, if this tag is present, then do this. If you don't see this tag, do this. And your program could actually get pretty sophisticated. I mean, I guess I'll leave it there in terms of the practical element. But there's a couple of things, maybe I'll end a little bit early, but there's a few things I want to kind of tell you about, which are practical considerations of web scraping. And because it's not all, you can't use what I've just showed you for everything. So I want to tell you that a few different things exist and just put them on your radar for if you run into specific kinds of problems when you're web scraping. But first, I want to give a few moments for questions. So, and I won't keep you too much longer, so don't, you know. But anyone have any questions before I tell you some of the other considerations you might run into web scraping? I'm going to insist on at least one question here. But I believe in you guys. Question. I can't have explained things that well. Well, okay, if you think of something, you can get on the chat or turn on your mic. A few considerations when you when you're scraping websites, practical considerations. So not all websites are like Wikipedia. Some websites don't want to be scraped. In fact, many don't want to be scraped. So there's a couple of issues that you're going to run into. And the first one is that people sometimes they will add checks to see if you're a human. And you've seen that before, which is the CAPTCHA, right? The little box, like, are you a human? And you have to click the box. And well, when you're doing things in Python, when you're scraping with your programming skills, you're not considered a human, you're a bot. The thing you're writing is a bot. So they're actually explicitly trying to make it so you can't write a program to scrape the website. There's one way to get around that, which is to use something different. It's called a web driver. And the main one that people use is called Selenium. But basically, instead of doing things in Python and just making requests from Python, it actually, on your computer, it will, you write the program, and then when the program starts, it opens the browser. So on your computer, you will actually see it happen. You'll see the empty browser opening up, and then you'll see it go to the web page that you tell it to go to, and then it will drive the page around. It will actually do whatever you want it to do on the page. So you tell it, like, click this button, grab this text, do this, do that. But the difference is that you're actually using all the exact thing you would do if you're human. So it actually will evade a lot of that stuff because you're actually using a real browser on a real computer. It's a lot harder for them to detect. The downside is it's slower. So you could, but it's kind of cool. If you do it ever, you will find it cool because it's like the website opens up and it's like driving around the website, like kind of like a Sorcerer's Apprentice kind of a situation with brooms or whatever, but it's just driving, it's like a ghost is operating your computer and it just does all the things. And you can get up and get a cup of coffee or whatever, but it is much slower than doing it this way, than doing it the BeautifulSoup way, okay? Another issue you're going to run into is JavaScript. And JavaScript is annoying because it runs in the browser and it runs in a very complicated way. So it can't be parsed by something like BeautifulSoup. It's too complicated. So you won't get the full website. A lot of the time, some weird JavaScript stuff will happen, and then you won't get when you use BeautifulSoup, you won't get the full website because it's JavaScript involved in building the website. There's a library that I will link you to in the notes after this workshop, but I think it's called Mechanicus or something like that. And if you're interested in using it ever, just drop me a line and I'll send you some sample code or whatever. But it's the library I found that's the most useful for first running some JavaScript and then getting the final page after the JavaScript does all its stuff. So JavaScript is really annoying for web scrapers because it kind of breaks the semantic nature of HTML, and it kind of it has to build the website on your end. So you need something to do that final step of building the website. And this thing Mechanicus or whatever it's called is the thing that I found to do that. The best, I guess. You can also use the WebDriver for that too. I'm trying to think of other issues that you might run into. I would also just say, make sure when you're web scraping that you're being ethical, right? I mean, I think it's perfectly ethical to scrape public data. But if it's a small website and you're hitting it really hard with your programs, you can sometimes cost them money, or even in the worst case scenario, you could actually bring the website down. Probably not with just what I've shown you, but it is possible. So just make sure you're being a good citizen and you're not doing what's called a DDoS attack or a distributed denial of service attack on somebody's website. Okay, it's probably not going to happen that your laptop is going to bring down a fancy website, but just make sure that, it's a certain amount of responsibility that you have when you do this kind of work. Okay. I think if people really want to know how to do the thing, I can share sample code. Just send an email to where you get all the links on the page. I think I would just have to write something a little more complicated, so it's probably not worth going into pedagogically in front of you. But I could share sample code because I have code from other projects where I've done that very successfully, but it's just slightly more complicated than is useful to just show you how to do it. And I think that's web scraping. And I hope you enjoyed this workshop. The next week's workshop is an introduction to data science. So we're going to be grabbing some structured data, not unstructured data like today, and it'll be in a CSV file, and we'll be exploring that data set. And it's a fairly large data set of Airbnb rentals in New York City, and it's maybe a few years out of date, but it's still, I think, quite interesting. And you can look up your own neighborhood, and we can average prices and do all this kind of data sciencey stuff with that data set, and we'll be using the pandas library for that. So I'll be around for a while if people have questions. Didn't seem like a ton of people had questions, but I'll be around for a while. I'll stop the recording and I'll hang out in the room to see if people have questions. But thank you for attending, and I hope to see many of you next week. And have a great week.